Hi everyone and welcome to MathSux. In this video we're going to go over trig identities and examples on how to prove them true. Then you can try the practice questions on your own at the end of this video. So first let's go over all the trig identities we're going to be using to prove things together. So first we have our trigonometric inverse identities. So these should look really familiar. These are just the inverse of sine, cosine, and tangent. Then we have the ratio identities. So this is just what tan of theta and cotangent of theta represents. So we have tan of theta is equal to sine of theta over cos of theta, and then cotan of theta is equal to the opposite of that. And last we have the Pythagorean identities. So the only thing you're gonna have to memorize here is sine squared theta plus cosine squared theta equals 1. But then from that we can derive all these other equations. So if you move around sine squared theta to the other side, we get cosine squared theta is equal to 1 minus sine squared theta, and you can move it around again and find what sine squared of theta is equal to. And the same could be said if we were to divide by sine squared theta by the whole thing. So 1 plus cotan squared theta equals cosecant squared theta, which gives us a whole other bunch of different equations we could play with. And then if we do the same thing, dividing the whole original equation by cosine, we'd end up getting tan squared theta plus 1 equals secant squared theta. So that's where all these equations come in. So don't worry about memorizing them all, just know that you can always divide by each trigonometric equation and you'll find everything you need to know. So now that we're familiar with the identities we're going to be using, let's prove these true. So up first we have 1 plus cosine of x over sine of x is equal to csc of x plus cotangent of x. So the first thing I'm going to want to do, play with this. We're going to be proving this and manipulating this part of the equation. And then this other side of the equation, we're just going to be leaving this the same. So just a rule for proofs, because proofs are a little different than solving an equation. We're going to be proving these two are equal to each other. So in order to do that, we're going to be leaving this as is, and we're going to be moving and manipulating this side of the equation so it looks like that. So that's our goal for these questions. So the first thing I'm going to want to do is just move around this fraction here, which is just fraction rule. So if we separate this out, we get 1 over sine of x plus cosine of x over sine of x. And then remember this, we're going to leave the same. So we're just going to bring that down, csc of x plus co of x. So just leaving that the same. And now let's see what we can do over here again. So we have 1 over sine of x. So remember that is the inverse of sine of x, right? Which is just cosecant of x plus, and remember this is a quotient identity, which is just going to be cotangent of x. So notice we didn't change the side and we got this equal to the other side. So this is equal to csc of x plus co of x. And we know our answer is right. So that's all we're doing with proofs. We're always manipulating one side and leaving the other side completely the same to make sure that it matches. So let's look at another example. We have tan of theta sine of theta plus cosine of theta is equal to secant of theta. So notice last time we were dealing with x, the variable, as the angle, and now we have this Greek letter theta. So either one, you might see either one of those, they all work the same, so don't worry too much about that. So again, our goal to prove these two are equal, we're going to be manipulating this, and then we're going to be proving this true and leaving this the same. So we're going to leave as is. So let's start dissecting this. So tan of theta. So remember that can be rewritten as sine of theta all over cosine of theta. Sine of theta, we're just going to bring that down and leave it the same for now. Plus cosine of theta, leave that the same. And then remember, we're going to leave this as is. Always leaving that as is. So now, what else can we do here? So let's just basic rules of multiplication. Sine of theta times sine of theta, that's going to give us sine squared theta all over cosine of theta, and then just bringing this down because we can't do anything to it, and then bringing this down because that always stays the same. So So now we have sine squared of theta over cosine of theta plus cosine of theta. So not sure what to do next, right? Well, what if we can get these on the same line? What if we can make this sine squared of theta plus cosine squared of theta? So let's just multiply this top and bottom, numerator and denominator, by cosine of theta. So then they could all go under the same, have the same denominator. So when we do that, this is going to be sine squared theta plus cosine times cosine. We'll get cosine squared theta. And then remember, the denominators are alike now. This is just basic adding fractions. Nothing fancy here. Cosine of theta is equal to secant of theta. So remember our Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. So this whole thing is actually equal to 1. So we're just going to rewrite that. 1 over cosine of theta equals secant of theta. And what is 1 over cosine of theta? That's an inverse identity, which is just secant of theta. So this checks out, and we did our proof. Question number 3. So we have tan to the 4th power of theta plus tan squared theta equals secant to the 4th of theta minus secant squared theta. So right away, we're actually going to take out a GCF. So everything we're doing, we're just manipulating and using the rules that we've always used in algebra and everything you're familiar with. So here we're going to take out the GCF, which happens to be tan squared theta. So when we do that, we're left with tan squared theta plus 1. And remember, we're always going to leave this side the same exact way, the right side of the equation. So this one's a little hard to remember, but this entire thing right here is equal to secant squared theta. And this is one of the Pythagorean theorem identities that happens when you divide by cosine squared theta. So here we have secant squared theta, and then over here, tan squared theta. That also, based on the Pythagorean identities, ends up being secant squared theta minus 1. So again, those can be derived at the original Pythagorean identity, and on the right side, we're just going to leave this exactly the same. So they're looking similar. So now what we're going to do is we're just going to distribute and multiply. So typical normal distribution rules. So when we do that, we'll get secant to the 4th theta, right? Secant squared theta times secant squared theta, just add the exponents. And then secant squared theta times minus 1 will just give us minus secant squared theta. And if we look on our right side, what do we have? The same exact thing, secant the 4th theta minus secant squared theta. So we know that we proved this correctly. So these are our examples that we went over in this video, but please check out the practice questions right here. The answers are up on my blog, MathSux.org, if you want to check those out, along with a cheat sheet that I also include on the website. So I hope this helped. Please give it a like and subscribe if it did. Happy calculating! Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!